So the unique pointer is just a simple replacement of the unsafe pointer. I made a simple wrap on top of an integer here. This is, we call it myInteger. It's a class that wraps up integer just in order to allow us to see where the integer is being constructed and deleted. So in the constructor has created, in the destructor destroyed, and also operator equal and get integer functionality. So this is a wrapper on top of integer just to see the process of constructing and destructing. So this is our function boo. And let's say we want to allocate memory for my integer. So we create a unique pointer of my integer that we call data, for example, and we make it unique. So by std make unique function. So data is the same pointer to my int as like a normal pointer that is expressed with my int star. However, this pointer is managed by the unique pointer class. So what it means that when the function is actually exited, we will have the allocation of the memory. So when the function boo is terminated and the data variable goes outside the function scope, the memory for the integer will be removed. If we run this program, we can see then when the program starts, the pointer is created, then we see the output of data 10, then the function is the function is exiting, and the memory is being destroyed. So we don't need to manually worry about memory. We can just forget about it. So the smart pointer will ensure that the memory is properly deallocated. Yeah. So the std make unique is example that came a bit later. So before in C++ 14. In C++ 11, people used to allocate memory with new operator, even for smart pointers. But then people decided that new operator is kind of old and it assumes that you need to manage memory manually. So they just replaced it by std make unique. Another important thing that unique pointer gives you is ownership transfer. That's something that you cannot do with raw pointers. So let's say you want to transfer, you allocated memory in one object and you want to transfer this memory to another object, but you don't just want to transfer data, you also want to transfer ownership, which means you want to transfer responsibility over this memory. So this is something you cannot do with the raw pointers, but you can do with unique pointers. This is an example. So in this example, we have the function foo that accepts a reference to a pointer. And inside this function foo, we create a data using smart pointer. So that's the same as we did before. We create data, but then in the next line, we move the ownership of this data into the pointer that we have here as an argument. And if you see where the function foo is called from, it's called from the main function. So in the main function, the function foo accepts the reference to another smart pointer that is defined in the main function. So actually we have two pointers here. One is inside foo function, another one is inside main function. So the memory is being allocated inside the foo function, but then we transfer ownership into the outer scope, into the main function here, data, and this is possible because of this std move construction that is called moving semantics. So if we have time, we'll also talk about this later. So in this case, you initially allocate data in foo function. However, the memory will be removed when the main scope is exited rather than foo scope, because you transferred both the data and ownership of the data. And if you run this program, this is the output you will see. You first create the pointer, then you see the print moved out from data, because when you are moving data from one pointer to another, the original pointer is actually being zeroed out. So it's null pointer now. Then the function foo is exited. You print 10. This is the content of the memory. You print it from the main function. And then only when the main function is exited, you are deleting the memory. So this is how memory ownership works. Okay, so this is unique pointer. One limitation of unique pointers is that there is only one entity that can actually own data. So that's something that Jiro asked. Can we actually remove std move here? No, we cannot. We get a compiler error because you cannot just assign memory, because assigning memory would mean that there are at least two entities that own data. So with unique pointer, it's not possible. So that's a huge limitation. That's why we have shared pointer.
Do you get the restriction? Why is it called unique pointer? If anyone has any doubts, right? Why is it called unique? What's so unique about the unique pointer? let's be more precise, right? Okay, so you allocate, right, a chunk of memory, right? You have an object in the memory, right? You allocate something in memory, right? Let's just call it object, right?
Mm-hmm.
And then the pointer is basically, what does the pointer do? It stores the address of that object, right? That memory object. Okay, so what's the relationship between this right, pointer and the object? What's the unique? Is there anything unique about this relationship?
The address.
I think the pointer. So there's only one pointer pointing to that address.
That's right. Yeah.
Right.
With unique pointer, right? So it only allows one pointer to point to that object.